In this video we will see stress analysis of a axis-symmetric component. This can be considered as a closed tube made from steel with a Poisson ratio of 0.3 and Young's modulus of 2 megapascal. A point load is applied at the center on the top and bottom of the tube towards outside of the cylinder. We have to determine the stress using Ansys. While solving the problem, we will consider the units in Newton and mm. Now let's go to Ansys. First we must go to preferences and select structural. Give OK. Next we must go to preprocessor, element type, add, edit or delete, add. We must go to solid and select quad 8 node. Give OK. Under options we must select element shape as triangle, element behavior as axis-symmetric. Axis-symmetric means the shape that we are defining will be symmetrical about an axis that we have to select during solving the problem. Now give OK and close this window. Next we must go to material properties, material model, structural, linear, elastic, isotropic. Young's modulus, in the problem they have given it as 2 megapascal. While converting it into Newton per mm square, it becomes 2 into 10 power 5 Newton per mm square. So we can give it as 2E5. Poisson ratio we can give it as 0.3. Give OK and close this. Next we must go to modeling. Create areas rectangular by 2 corners. First let us give the x and y coordinate values as 0, 0. The width is 20 mm and the height is 5 mm. So the bottom rectangle will be created. Now we must create a rectangle here. So the x coordinate value is 5 mm from this end. So x coordinate value is 15. Y coordinate value we can give it as 5 because from here this is y equal to 0 line, this is y equal to 5 line. We must start from here. So y coordinate value 5. Width is 5 and height is 90 mm. Give apply. Now we have to create top rectangle. For that the first point is x coordinate value 0 and y coordinate value 95 mm from the bottom. Next width we must give it as 20 mm and height as 5 mm. If we give OK, top rectangle will be created. Next we must go to operate and under booleans add areas. We must select the 3 areas and give OK. Next we must go to meshing. Under meshing first go to size control, manual size, all areas, and element edge length we can give it as 2 and give OK. Next we must go to under meshing, mesh, areas and select free, give pick all. The meshing will be done. Next we must go to solution, analysis type, new analysis, select static and give OK. Next we must go to define loads, apply, displacement, symmetric boundary condition, on lines. We must select these 2 lines so that the element will be considered symmetric about this axis. Give OK. Next we must fix this structure from moving along y axis. Otherwise if we apply load it will move along y axis and no stress will be there. So for that we will fix the center. For that we must go to select entities, nodes by location and select y coordinates. Give the value as 50 and give OK. That is, along y coordinate value 50 all the nodes will be selected. Now under displacement go to on nodes, pick all and select displacement along y axis and give the displacement value as 0. Now all the nodes at y equal to 5 will be fixed. Before applying other loads, first we must select all the nodes. For that, again go to select entities and change this to by number or pick. Give select all and give OK. Now under force or moment on nodes, select this node, give OK and give the Fy value as 100 Newton. Similarly on the bottom point, give Fy value as minus 100 so that it will act outwards. Now we can give solve, current ls, select OK. Once the solution is done, close this. For viewing the results, we must go to general postproc. We must list the results for stress values for the thickness of the axis-symmetric element. So we must go to select entities by location, give the minimum and maximum values 45 and 55 respectively and give OK. Now if we go to nodal solution, select y component of stress under stress and give OK. The stress values will be listed here for the nodes between y equal to 45 and y equal to 55. Now if we take average between the minimum value and maximum value, the minimum value is 0.17866 and the maximum value is 0.18552. If you divide it by 2, you will get 0.182. So this is the value of stress. By doing manual calculation, you will obtain the same result. Thank you for watching the video. We will see other problems in the upcoming videos.